And with this, thanks you all for joining us today for our 10th Roundtable, the BatteryMBA Roundtable, looking at a range of perspectives on the future of batteries. My name is Dr. Simon Engelke. I'm the founder and chair of Battery Associates, and I'm extremely delighted to be here with you today to have some really exciting thought leaders from the battery space, from different aspects of the battery space with us. And yeah, I think it's going to be a packed, fun few hours, or at least 45 minutes for everyone joining us online. And if you're watching this right now on LinkedIn or YouTube, feel free to also introduce yourself in the chat, in the comments. Feel free to share where you're calling in from, share an interest you have with us as well. And hopefully you'll be able to submit some questions later on this way as well. So really can make it interactive, because we would love to hear from you as well. But of course, let's get started. Who are the speakers today? Shada, do you want to kick it off?
Yeah, thank you very much, Simon. Welcome everyone to our BatteryMBA Roundtable 10. We're very honored today to be with you, and we have very important names joined our panel today. So let's begin with introducing our panelists. And the first panelist is Richard Bouvret. Richard Bouvret has been at the forefront as CEO and chairman of e-mobility and smart grid initiatives at Blue Solutions, part of the Bolloré Group, since September 2022, with a deep understanding of vehicle life cycles, expertise in mechanics, and a keen eye for cutting-edge technologies. Bouvret focuses on innovation within the sector, tasked with transforming Blue Solutions into market leader for solid-state batteries and electric buses. His expertise is vital in navigating the company towards future technologies. A graduate from École Nationale Supérieure des Mines de Nancy, Bouvret brings over 30 years of experience from his time at Valeo and ZF Group, where he led development strategies, commercial transformations, merger and acquisition efforts, setting a strong foundation for his current role. For the second panelist, I will hand over back to Simon.
Thanks so much, Shada. And yeah, Lina Emerson, she's a qualified and experienced chemical engineer and senior leader with a deep interest in clean tech, and she's passionate about having a positive impact for the future of sustainability. She's an experienced leader in early-stage battery companies, executing major programs and building high-performing teams. Currently, she's serving as the CEO of Nidec Energy, a pioneer in long-duration energy storage solutions, utilizing the 24M technology in the form of Freya cells. Previous roles include Northvolt and Britishvolt in cell manufacturing, as well as SaaS business CEO and a broad experience from the pharmaceutical industry. Additionally, she serves as an advisor to clean tech startups in the battery industry. She's committed to sustainability and impact businesses to decarbonize the world. So Lina, big welcome to you as well. With this, over to you, Shada.
Thank you, Simon. So our third panelist is Abdurrahman Raji. Dr. Abdurrahman Raji, the Chief Technology Officer at Zeta Energy Corporation, brings over 15 years of experience in pioneering lithium-sulfur battery technology and carbon nanotechnology. With an impressive portfolio of more than 45 patents and research publications, alongside an H-index of 22, Dr. Raji is a distinguished figure in battery technology sector. His academic achievements include a PhD in chemistry from Rice University and a postdoctoral work at the University of Cambridge, where he led the establishment of Energy Storage Lab and the Dry Room, a cornerstone for battery research and prototyping. At Zeta Energy, Dr. Raji drives the technological vision, leading innovation in battery materials, cell engineering, and the commercialization of next-generation storage solutions. His work exemplifies a deep commitment to bridging cutting-edge research with practical technological advancements. With this, I hand it over Simon again for Battery Associates.
Thank you so much, Shada. And again, big thanks for everyone joining us today on LinkedIn and YouTube, and of course, all this fantastic cohort as well of the BatteryMBA. This is just going to be a super quick few slides about who we are as the organization hosting today. Battery Associates, you can see it here. Our mission is to create a sustainable world through the power of people on battery innovation. So we hope you're all part of this mission. And we do this in a couple of different ways, including Battery to You, which is our educational arm, where the Battery MBA is really our flagship program. So really fantastic to have all of you here from this cohort with us as well. Then we have Battery Pro, which is more consulting and recruiting services we're offering with that. And then Battery Lab, where we're actually developing our own hardware and software, mainly our battery cycler for battery testing. With this, over to you, Melanie, for the Battery MBA.
Thank you. As Simon mentioned, education and training make up one of our key branches, and Battery MBA is our flagship program. For those who don't already know, here's a quick overview. It's a CPD accredited 12-week online program that we offer 3 times a year. We have more than 460 alumni from over 50 countries, and more than 25% are female participants. The program is meticulously structured to accommodate full-time professionals with a manageable time investment of 2 to 3 hours per week. Our participant base represents a diverse array of companies actively engaged in different stages of the battery value chain. As you can see here, our alumni network includes professionals from leading organizations such as Tesla, Lifecycle, PowerCo, Jaguar Land Rover, SVOLT, BASF, prominent universities worldwide, among many others. You can see here from the testimonials we receive, past and present participants have very diverse profiles, from research to manufacturing to policy. Our goal here is to help train this diverse and global battery workforce across the entire value chain. Have a look at the testimonial page for yourself to see how battery training has helped various individuals on their own journeys. If you're keen on joining our program, we invite you to apply for our upcoming cohort starting in May. Additionally, we're pleased to offer a range of scholarships designed to facilitate the inclusion of individuals from groups that are traditionally underrepresented in the battery sector. Another way we participate in the industry is through our own Women in Batteries events. We had an incredible Women in Batteries event in October featuring MBA alumni Dr. Crystal Waters, and we're excited to share that our next Women in Batteries event will be on the 17th of April at 4 p.m. CET for women and those identifying as women. You can see the event invitation on the Battery Associates LinkedIn page. Finally, we are excited to share that our 5th annual event, Battery Day 2024, is scheduled for the 26th of September. This full-day online event features leaders from various industries and showcases panels and deep dives on pressing battery developments. We cordially invite you to register using the QR code or the link provided here. Now, I'm going to turn it over to Simon and Shada, who will be kicking off our roundtable.
Thank you so much, Melanie. Yes, and with this, again, we want to go to our fantastic panelists of today, Richard, Lena, and Abdul. And yeah, also an invitation already to all of our current participants of this Battery MBA. Feel free, as usual, put your questions in the chat. We want to get, this lively discussions going, which we had over the last 12 weeks or so now. And then, of course, also anybody online on LinkedIn and YouTube, please put your questions in the comments so we can address them as well. We try to get through as many as we can. From experience, time runs out in the end. So please be fast and put your questions in early. With this, over to you, Shada, for the first question.
Perfect. Thank you. So for the first question, I want to turn to Richard, and I want to ask him about solid-state batteries. So the question is, given your leadership in solid-state batteries and smart grid technologies, Richard, how do you envision the integration of solid-state batteries in the e-mobility ecosystem? And what are the expectations of OEMs? So could you please shed light on the challenges also of scaling up solid-state battery technologies for widespread electric vehicle adoption?
Yeah, thank you very much first, Shada, Melanie, and Simon for the introduction. Yeah, solid state, for Blue Solution, this is a story for the past 12 years of production, serial production. So we are not at the gigafactory, but we are producing serial product with a mega company, less than gigawatt hour. How we see that in the future, how we see the scale up. First of all, when you want to go to solid state, you need to master one part of the battery, which is the electrolyte, and you need to be able to scale up this product. You have a different technology. For us, we are working with solid-state battery with polymers. And the challenge is to develop a polymer that will work at the ambient temperature and to build, from the monomer to polymer, to build, from the scratch, a specific polymer that will be able to work at the right voltage, at the right temperature, and that will allow the battery to have to reach the cycle numbers imposed by the customers. If you take passenger car, very basic, 1,000 cycles, for example, and that this is something that we need to work. And the challenge is to be able to scale the polymer, because when you build monomer to polymer, you are building few grams, and then you have to build half a kilo, and then few hundreds of kilo, and then you go for the tons, and then bigger. But then you need to have a different a partner to do that. And when a polymer is working for a few grams, doesn't mean that it will work for a few kilo. This is not so easy. Okay, science is good, but it's not so repetitive in polymers. Plastics are very, dodgy guy. They are playing with us. So we are working on that. This is one of the challenge as well. We have anode in lithium metal, but for us, we are at TRL9 since more than 12 years, and we're able to produce the quantity of lithium foil with 20 micron thickness with +1, -1 micron specifications on kilometers. So that for us, it's something that we are able to even offer to the market, to the other battery players. And after, with that, we need to be able to create a polymer that will work nicely with any kind of cathode. And we have developed for us a new Gen 4, which is working now. And we have reached 1,000 cycle that can work with different type of cathodes, LFP, LMFP, NMC. The idea being agnostic to the cathode, because we will go to gigafactory, and the challenge is to go to giga problem become a huge problem in the future. So then we are working on that. Sorry, I'm talking too much on that, but this is our life on daily basis, and this is what I can share with you on that.
Yeah, amazing. Thank you, Richard, for that. Yeah, I understand the difficulty is really from lab to mass production. That is very, very real challenge for the OEMs. And thank you very much for all this insightful information about solid-state battery. So we can continue with Lena now. Simon.
Absolutely. No, thanks for this, Shada. Yeah, I got a question for you, Lena, to kick it off. So Nidec Energy's partnership with Freya Batteries positions you quite uniquely in the low carbon stationary energy storage market. How do you see your innovative cell technology impacting the resilience and sustainability of global energy grids, particularly in regions with high renewable energy penetration? Additionally, what are the major technical and market challenges you anticipate in the next 5 years?
Yeah, great. Thanks for the question. Yeah, this is really exciting cell technology, spinning off of the 24M core technology and in through to Freya manufacturing. And this is really a game changer because they have so many, it's a fewer steps in the production. So they save a ton of energy, and they also save on the footprint. So making this really a good low carbon cell to then take further into the energy storage markets. It's very tailored to energy storage and the long duration energy storage. So we see that increasing now, especially with the solar integration, as you mentioned, Simon, where you're looking for longer duration batteries because you typically cycle solar throughout the 24 hours of the day, right? Where you charge during daytime and you discharge during nighttime, etc. So long duration storage is really on the up, and this cell is tailored to that long duration. There's also actually a great environmental impact here because this is actually PFAS free. And for those following the European legislation on PFAS, you know that is becoming challenging. It's a really severe, environmental poison, if you like, right? That we do not want to discharge to our waters or anything like that. And legislation might actually come in to to be a bit harsher on this as well. It's also NMP free. So again, another chemical that's a bit challenging from a legislation perspective, and health and safety as well. So there are other benefits to it. Then, of course, there are technical challenges. So following on the question here, it does take a bit more in terms of pressure management, temperature management, and we need to be a bit more sophisticated on the module level. So you actually have quite high tech on the module design that you wouldn't have to on more conventional type cells. Then, of course, there is a big market challenge in the energy storage space. What I typically see is energy storage is a bit behind on the ESG space. Customers in the market are not asking as much for low carbon, for sustainability, for ESG. Cost and price is still a major driver here. So it's really, really important to be able to penetrate the market also with a reasonable pricing, because the market isn't prepared to pay too much extra for good ESG credentials, unfortunately. I do hope this will change as the market matures as well, and that we will see a bigger sustainability drive. Of course, legislation in Europe is already pushing also energy storage in that way. And the market challenge we see today is the very challenging price levels we do have out of China. So obviously Europe and US needs to be able to meet those price levels or be close-ish, which is of course also why the IRA came into place, to be able to actually plug that gap. So yeah, but it's an exciting space to be, and energy storage is really, really on the up as we're putting more and more wind and solar power around the world. So we need energy storage for multiple purposes to, well, store the energy, of course, but also to balance the grid and make sure that we actually can integrate sustainable energy sources.
Fantastic. Thanks so much, Lida. And yeah, I think some really interesting thoughts we will pass on, or we'll tackle a bit later in the question as well. And that's just another encouragement to all the participants. I already see some questions coming in here in the chat, but also want to give the people online. I know there's quite a few of you. We can see probably one of our higher turnouts here, which is fantastic to see. Please don't miss the chance to ask your questions, because I think afterwards you're going to send me some messages and going to say, I wish I would have asked this question to the fantastic panelists. So yeah, please go ahead and ask your question now on LinkedIn, so we still have time to address this, because we have the first 45 minutes, which is public to all, and then the second part is only for the current BatteryMBA participants. But with this, over to you, Shada, for the question to Abdul.
Thank you very much. So we start with solid-state batteries. Now we're going to transition to some other next generation battery technology, which is lithium-sulfur. So my question to Abdurrahman would be, with Zeta Energy pioneering work in carbon nanomaterials-based lithium-sulfur batteries, which replace actually conventional materials like graphite and NMC. What do you see as the primary hurdle and opportunities in transition from traditional lithium-ion battery technology to lithium-sulfur technology at scale? And additionally, the following question would be, how does the environmental impact of lithium-sulfur batteries comparing to conventional lithium-ion batteries? Can you please comment on that, Abdurrahman?
Yeah, thank you for the introduction, and really happy to be on this panel. I go way back with Simon since our days at University of Cambridge, and I've heard really fantastic things about the BatteryMBA program from many executives and professionals in the industry. So really glad to be a part of this as a speaker today. There has been a lot of expectations about battery technology in terms of lithium-ion battery and how they'll play a key role in the industry in terms of cost parity between electric vehicles and the internal combustion engine. There are many forecasts or expectations that by this time of the decade already that this lithium-ion batteries should already reach cost parity. But what we've been seeing has been challenges from metal oxide-based technology in terms of the raw materials availability in the previous years, and also the rising cost of these materials, and more importantly, the forecast in challenges with availability and cost of the raw materials that go into the NMC technology, nickel, cobalt, manganese, and graphite. And also more significantly, the complex supply chains that's marked by geopolitical gamesmanship surrounding these materials. I think this opens a lot of opportunities for next generation battery technology, specifically lithium-sulfur battery, where you're taking a low-cost material, sulfur in this case, and then transitioning that to develop a battery technology that's low-cost, that's widely available, and that could really offer a substantial value for widespread deployment of battery in electric vehicles in the years to come. One of the key things in lithium sulfur is, as you scale the technology, you're looking at sulfur and then the grade of the sulfur and the type of sulfur you put in your battery. And what you find is that as you narrow down on that grade of sulfur, where you're thinking, oh, but sometimes people try to purify and get the highest purity of sulfur. Well, the processes for purification of this, start to add cost, to the sulfur. So in a way that, might take away from some of the low cost advantage of the material. What we've done at Zeta is to see and say, well, we need to use sulfur from refineries, and we've actually, taken sulfur from refinery. And the challenge from sulfur from refinery, because it's a byproduct, and there are many different grades and flavor within a given refinery and between refineries, and then developing a process, that take advantage of this low-cost sulfur. What we've done at Zeta was to develop our process around this sulfur in a way that the process become robust, where you're taking advantage of the fact that of these low-cost materials and make the process insensitive to variability in the raw materials, and preventing that variability but from being transmitted to the active material that comes from this sulfur material, which is very important in driving the low cost. That's very important to get widespread adoption. So a key part is that getting this sulfur, which already is a byproduct from the refinery, but also what comes with that is that you get more sustainability in terms of the environmental carbon footprint. You get low carbon footprint from this material. So I think the future of lithium sulfur needs to move in this direction, and the way we're approaching that is refining the processes and adapting the processes to become robust and insensitive to these variabilities, because the variabilities will happen. What you don't want is to have to purify the sulfur and add many processes to the sulfur purifying, which add to the cost, add to environmental carbon footprint as well. So that's one key part. The second part, the hurdle that has been prevented lithium sulfur in many years in reaching its fruition is the polysulfides that form on the cathode. Whereas you put lithium on the sulfur, you start to generate polysulfides that leach into the electrolytes, and it goes into the separator. In fact, in the past, when you open lithium sulfur cell, you see this yellow material that forms on the separator, and that could also migrate to the anode, where it could also degrade the anode as well. What we've done at Zeta is to attack the problem at the fundamental level, where we're creating bonding between carbon and sulfur in such a way that as you lithiate the material, you don't leach polysulfide into the electrolyte, and that enables long cycle life, which is required for electrification. I think this opens up opportunities for adoption of the technology. Oftentimes, people forget that in a lithium sulfur, you have two electrodes, the cathode and the anode. So not to forget about the anode, because it's very important. Lithium metal has been notorious for forming dendrites, where these tree-like structures that grow into the electrolytes, and then the separator potentially causing short circuits. What we've done is come up with a high surface area carbon material, where you carefully form a robust SCI on these forest of aligned carbon nanotubes, and then plating lithium metal locally on the sidewalls that's protected by this robust SCI, tens of nanometers of lithium metal on each nanotube, which enables long cycle life and also prevents the dendrite formation. So this key development, I think, creates unique opportunities for advancement in the field and removing the hurdles and barrier that have prevented lithium sulfur from being commercial reality, but also from the performance and also the low cost availability of the material. I think we're gonna see lithium sulfur become more and more an key industrial player in the years to come. Will you see lithium sulfur battery electric vehicles this year or even next year? Probably not. But as we move into the later part of the decade, 2027, 2028, this technology are going to become more mature, and with the developments and the price makes sense, the availability makes sense, and as you remove hurdles from both the technology and also the scale up, I think by 2027, this becomes a key part of how we drive electrification and achieve that cost parity with internal combustion engine, maybe even surpass the internal combustion engine vehicles with battery cost lower than $50 per kilowatt hour. That's really the potential with the lithium sulfur. In terms of environmental footprint, the great thing also about using, at least for our technology, is that we're using these hydrocarbons to make the carbon nanotubes. Now we're developing technology where we could use carbon dioxide as well to make carbon nanotubes, and this fits back in a way that reduces environmental carbon footprint to enable us to drive the technology forward. So I think both cost, availability, environmental carbon footprint reduction, in the years to come, software technology will play a key role in driving industrialization and commercialization as we get to look for more widespread electric vehicles in the industry.
Thanks so much, Abdul, and great to see you kept the passion from our good university days in Cambridge on this topic. So really good to have you. Thanks for that. And fantastic. So I think now we have already a couple more questions coming in online, as well as a lot of them here in the court, which is great to see as well. I think I will pass over to you, Shada, for the first question. Richard.
Yeah, thank you very much. So Richard, there is two questions for you about lithium metal batteries. So some of the companies, they're moving actually from they're moving to silicon-based anode instead of lithium-based anode, lithium metal-based anode. And what is your opinion on that? That is your first question we got, and we also have another question. If you want, you can comment on that, and I can ask the follow-up question.
Yeah, of course. Thank you, Shada. Very, very interesting questions. Yeah, it's clear that to go to silicon-based, it's and if you want to be able to produce battery, solid-state battery for tomorrow, I think today most of the company they will try silicon-based. That's because it's easier to move with that. I say that lithium metal today we are doing that since many years. This is our core business, and for the people who have already touched lithium metal, they know the difficulty to produce, to laminate and to be able to produce at the right size, and after you have to manipulate it, okay, right, to make your battery. And that it's far more difficult. You need a very strong knowledge and long experience to do that. And I understand, but at the end, if you choose a silicon base, it's easier to do, but you will never claim the same energy density than the lithium metal, right? So it's a choice. It's just a choice. Less challenge but less density, or more challenge and more density of energy. So I think in the roadmap, for higher density, I think we will go first for a silicon base, then we will go to lithium metal. Most of the battery makers are doing that. For us, we decide to go directly to lithium metal because we are able to manage the lithium metal, right?
Mm-hmm. Yeah, we all know already Blue Solutions worked with lithium metal years ago, actually, with the polymer electrolytes. So the next question from the audience is can solid-state platform used with all chemistries that like LFP, NMC, lithium metal, and what is the preferred chemistry?
It's very, yeah. It is obviously it is good if you got one polymer that is agnostic to the technology of the cathode that you can put, because when you think manufacturing on giga factory, it's becoming a big headache to have different, I would say, polymers. Of course, that will be nice, or different other electrolyte that are not like us. But for me, I think, and we are proving that we are able to manufacture electrolyte today that will work at, that are working at ambient temperature, and that are able to go to the voltage of an MC, high voltage. So it's not a trouble. And I think if you all the time think manufacturing giga, what is the end of the manufacturing and how to make it simple, it is very important to have a one type of electrolyte. And this is what we are doing. And yes, we can work today with LFP, LMFP, and NMC. It's just if you want to have a battery with that will be more costly but more high density, then you will go with NMC. But if you want something a bit far more competitive, a bit less than I would say energy density, you go LFP. But keep in mind, a solid state battery lithium polymer 4th generation with LFP will be still far higher in density than the best of the lithium ion with NMC. So this is very important to keep that in mind.
Yeah, thank you very much, Richard, for this excellent insights. So let's continue with the Lina's question now.
Thanks so much, Shada, and thanks so much, Richard. Yeah, there was another question from our audience, actually an alumni from the BatteryMBA. Philip, great to have you here, and he's thanking you for the great introduction, Lina. So he has a question about the production, right? And I'm not sure if something you can comment on, because it might be less connected to what you do, but there's a question about shifting production from FREYR from Scandinavia to the US. Will it affect the carbon footprint? Is the question, as renewable energy share in the US is quite lower. Thank you. If there's anything you can share on that.
No, thanks for the question. I think that is very, very relevant. So, I mean, the product design and the manufacturing design as such is already a lot lower carbon than conventional because there's fewer steps and this is not as high intense in energy usage. I do not actually know exactly what energy sourcing will be on the table for FREYR in the US. It's in Georgia, but the DNA of FREYR is all around sustainability. So I can honestly not imagine that they would run any factory without having 100% renewable energy source.
Fantastic. Thanks for sharing this, Lina. I think then we have one for Abdul. Shada, would you like to go next?
Sorry, yeah. So Abdul's questions. How are the challenges for lithium-sulfur batteries being addressed? The solution of sulfur electrode, poor electrical conductivity, and special additives coating being used for? And how are the volume changes which are significant in such batteries addressed? And the other one is that when it comes to safety, how safe are they compared to sodium-ion batteries?
So what we're doing for the lithium, the polysulfides and electrode stability is really making a compound of sulfur and carbon. And this compound, we start with sulfur with some polymer, the type of polymer you typically see in making carbon fibers. And then we also have some carbon additives that are added in this precursor mix. So as part of that precursor mix, this carbon polymer eventually turns to carbon. And then you have additional carbon additives in the precursor, and you have sulfur. So by the time you make that material and all of these different components react, you end up with a sulfur that's bonded at the atomic level with the carbon. So in the near vicinity of that sulfur, you have a carbon that's nearby, and you're not relying on some mixing, post mixing of carbon with the sulfur, where you don't have very good contact between the carbon, but rather the sulfur is bonded, strongly bonded to the carbon. So this is the way that we reduce the resistance and improve the conductivity of electrode, but also importantly create an electrode that doesn't leach out any polysulfides into the electrolyte. So it's a unique solution because it addresses both problems of conductivity and electrolyte stability at the same time. And the second part, in terms of the safety of this material, one of the things that we found in this structured architectured material is that we did some thermostability testing, and these materials don't start to decompose until several hundreds of degrees Celsius. With NMC, they started to decompose after a couple of 100 degrees Celsius. So they're remarkably stable in that sense. And we've done a lot of studies on this for also our anode as well, where we have the carbon nanotubes that enables us to prevent the dendrite from forming. So these two key parts, we see, the engineering at multiple length scale, from the atomic scale, from the electrode scale, and also at the cell level. At the moment, we're doing a lot of robust testing. We're collaborating with national labs, doing testing, abuse testing on our cells, electrodes, and cells. And in the months to come, we're going to be releasing results about this. But the foundation really, is there at the electrode level to drive that improved safety for the cells.
Yeah, thank you very much, Abdul, for explaining that, especially how you managed with your electro technology, you managed to stop the polysulfide shuttle, which has long been investigated as an issue for lithium-sulfur batteries. So we have another question, which is for Richard. I can ask that quickly. Bolare solid state battery has about 20 minutes warm up time. Would you consider using fast direct resistance heater like EC power heaters to warm up the battery in 2 minutes? Why or why not, Richard?
Yeah, it is when we talk about the previous and existing solid state that we are manufacturing. They are used for city bus and different applications, that it's true required to be warmed at 80 degrees to allow the polymer that is used, the type of polymer to be warmed up, right? And we are using a system to warm them up. And of course, there is many new technology that we are considering to apply until we are able to put in the market the Gen 4 that is working at ambient temperature. Yeah, of course, we are very open to use any kind of technology to accelerate the warm-up. Warm-up is necessary for the people to know when you put your battery into sleep, okay? And when your battery is sleeping for days and days, when you want to restart to use it, and then you have to warm it, okay? Otherwise, when the battery is used, plug, unplug, use, you don't need to warm it. So it's the way, it's yeah. I hope that I'm answering on the question.
Yeah, that is perfect. And so we can now.
I think I can quickly, because I think I'm looking at the time shader. So I think we're almost out of time. So big thanks already for everyone joining us live. We're not over yet, but we're getting close to it. I just want to quickly say big thanks to also our speakers, but two quick things. So one is for our speakers, the next question I'm going to ask you, we're going to look at what is the future of batteries, right? That's the perspective on the future of batteries. That's today's topic. You all represent, I think, some really exciting technologies and industries, right, which have a lot of momentum, a lot of growth potential, etc. So maybe as closing remarks, which you could maybe lay out a bit, what is your perspective on the future and batteries to each of you as a closing remarks. And then also I want to say big thanks already for all the current BatteryMBA participants who are having lots of questions. So once we finish in this live stream, we're going to continue on that. But again, for our live stream, for all of the people on LinkedIn, on YouTube, anywhere online, again, these closing remarks would be fantastic. And maybe, because Richard just went now, maybe we can do the other round. We start with Abdul, and then we go Lina, and then Richard.
I think as regulations mature and catch up with the development in the battery industry, what you're gonna see more and more is more complete the request or requirement for more complete life cycle assessment in the battery industry. Oftentimes, people start their life cycle assessment from when the material enter their factory, while neglecting that the fact that there have been many processes on the material, on the raw materials. Take for instance graphite. You have the graphite mining, you have the purification, the refining, the shaping, and all of these different processes that lead to the release some impact on carbon footprint. But as we move on, all of this will need to be added in the life cycle assessment. And this, I think, will provide new opportunities for next generation batteries that are already addressing the carbon footprint or impact in the development of their materials and processes. So this is going to be a big part of how we move forward in the future.
Fantastic. Thank you, Abdul. Dina.
Yeah, for me, I think we're going to see a lot of proliferation when it comes to new technology and innovation, all the way through from novel materials through to really novel cell technology through to novel recycling methodologies as well. We already see all of these startups all across the world, right? As Abdul mentioned, getting your graphite or nanotubes out of your CO2, or there are other companies doing it from waste wood chippings and waste organic materials, for instance. And also all of these new cell technologies that will stop using harmful chemicals and actually drive a lot of environmental improvements also in the battery space. So I'm quite excited to see this. So it's not one solution fits all anymore. It's going to be a very specific battery world we're moving into.
Fantastic. Thank you. And Richard.
Yeah, first of all, I think that battery, we will face in the future a big diversity. This is clear. We can talk about any kind of technology today, even though we are observing some mega trend on cathodes. You look at China and they are moving very carefully to LFP, LNFP, that will be done on cathodes. On the other side, on anode side and on polymer, on the electrolyte, of course, big diversity will come. But what is important, I think it's very important when we think battery, we have to have in mind all the value chain in the holistic manner. And I think Abdul was mentioning something important is when we talk about the raw material, the material processing, the component manufacturing, the cell, the module, the introducing that into the chassis or for e-mobility, whatever it would be, a passenger car or two-wheelers or whatever, we have to consider that in the holistic manner in the future. Because battery will not be electrochemistry in the future. Battery will be also associated to a strong ecosystem of, I would say, digitalization about power electronics. And that has to be taken into account. When you design your battery, you have to introduce inside the design to circularity from the beginning. The real added value in the future, the USP of the product will be there at the design point, if you have the courage and the will to really introduce that in the design of the battery at the beginning, from, I would say, from the mind till the full recycling, it has to be incorporated. And it's a very long number of equations, a system of equations for the mathematician to solve. With all these equations, you have a very few solutions, and we will have to work on that. And I think that the dual chemistry in the future also, or even more than two chemistry will come, because sophistication of power electronic, of management profile, usage profile of the customer will be very different in different country, different region, urban, not urban, and so on. So a lot of equation to manage, to sort out big diversity. And then it means we have to be nimble. We have to learn fast, and a lot of cooperation will operate, together in order to supply the right battery systems to the customer in the future.
Thank you so much, Richard. And I think with these words, we want to close it for the public part. again, a massive thank you for the fantastic panelists, as well as all of you out there on LinkedIn and YouTube and anywhere else you're going to watch this, I'm sure later on, some of you. So again, big thanks for being with us today, sharing your questions, your thoughts, and again, stay in touch. And if you're interested in Battery MBA, feel free to get in touch. Quite a few of you already took the program maybe, but there might be some out there who haven't yet as well. So with this, we're going to stop the live stream.